इतने पीछे बैठोगे तो कैसे सुनाई देगा? ओके, हेलो, आवाज आ रही है ना माइक की? Okay, so in the last lecture we had discussed about natural language basics, in which we have seen that what are the various stages are there in which we can process our text. Now in this lecture we will see that what is the basic procedure we follow at the time of text mining, right? So if you have data, what is the basic procedure you will follow? What is the architecture, basic architecture of text mining process is there, right? So in the process of text mining, at first, as you know that whatever application you are building or for whatever purpose you are building your model, the very first requirement is that you need the data, right? So for that you have to collect at first the data so that we can process that data, or on the basis of that data we can build our model, right? For suppose that you would like to build your model on for weather forecasting. So how you are building your model? On the basis of data, right? So what is the previous history is there? It will analyze that data, and on the basis of that it can take the decision. Your model would be able to take the decision that what would be the weather forecast. So for this purpose you would at first the requirement of data collection. So in the data collection and extraction, the very first thing what you can do, you can just do manual techniques you can follow to collect your data, right? Like you can go to the web, and from there whatever the relevant documents are there, you can just copy paste that content into your format and you can collect the data. Or if you are needing something novel data, you can do the surveys, or you can take face to face some interviews so that you can get the data. But you know that if you are following this particular method, that you are not taking any novel data and you are following the method of copy pasting, that would take more and more time. That would be very complex, or we can say critical process for you, or time taking process for you to collect the data. Because in the machine learning or deep learning, if you are building your model, you would have the requirement of a huge data, right? In machine learning, somehow you can build your model using less data, but in deep learning you would require the more and more data. So for that purpose, what you can do, instead of taking this particular method of copy pasting or manual entry, you can follow the automatic methods, right? In which you can automatically extract the data relevant to you, right? So what are these techniques are there? Like web scraping are there, or you can follow the API. Using API you can do the same thing, you can extract your data. So if we talk about the web scraping is the technique in which you can, if you would like to extract the data from the websites for your particular interest, you can use several extensions, or you can use the regular expression methods through which you can scrap the data from that, right? So what is happening that in web scraping, what is the advantage of that? For suppose that you would like to extract the data of a particular product, in which you want to know that in various websites or in various sources, what is the price of that product is there, right? So in that case, you can do the comparison easily from various sources at a time. You can extract the data for that particular product, right? So this is the advantage of web scraping. You can follow that. Another is API integration. You can do, you can use this particular method. So in API integration, you have some integration, your interface, interfaces has been given through which you can extract the data. What do you mean by interfaces? Can anyone tell me? What is interface? Can you explain in very easy form? What is interface? Yes, or it would make you able to send the request to the server through a particular software, or to take out from the server any responses, right? So API, you can do this. Through API, you can do this. So if in a very simple way, if we are defining the interface, it is just for with any device, if you will see, you have the provided with an interface. Like if you are if we are talking about fan, the switches are interface, right? Switches are acting as interface. You have to know that how to use these fans, or how to use any particular device through that switches, right? You don't need to understand how internal mechanism is doing for a particular function, right? So that is interface. You would have provided the interfaces. So similar, in every software, you would have some form of APIs there through which you can interact with any kind of applications, right? So these kind of APIs you have given, you can use that APIs to extract the data, right? Later we will see that what are the different methods are there, or what are the different methods for web scraping is there. We will see in detail, but here we are discussing an overview of text mining process, right? So this is about the data collection and extraction. After collecting your data, you need to pre-process your data. Since your data, whatever the data you have collected, that data is not ready for machine learning algorithm to process in that format, right? So for that, you need the pre-processing. And in the pre-processing part, the very first stage is to clean up your data. So in the clean up your data, suppose that in your data some unnecessary tags are there, or some unnecessary information like advertisement information is there. So if you would like to remove that in that particular phase, you can do that, right? So in the cleaning of the data, you are making your data relevant to you, right? You don't want unnecessary content in that. So that's why you are doing the cleaning up. Then tokenization. Since we are talking about the text data, so in that context, tokenization is necessary to recognize every unit of a particular text. Whether it is you are identifying your text in the form of sentence unit, or word unit, or phrase unit, right? So every sentence or every word has been recognized, so that you would have to do the tokenization, right? So you are splitting your text into smaller textual units, so that you may know that how many words are there, or how many sentences are there, which you have to process that. Another is stop word removal. This is another pre-processing step to which you can follow, but this is not necessary. It is optional. right? In some application, you need this particular processing, and in some another application, you don't need, right? Like in machine translation, you don't need to remove the stop words, because in the translation, what is happening that you are translating your uh, sentence from one language to another language, in which there is a higher role of grammar, right? It will play a very major role uh, to translate one particular textual unit, right? So if you are removing a stop word, so what is this stop word? Stop words are those which are occurring very commonly in your text data, but they have not any essential meaning in that, right? Like prepositions you are using, right? Preposition in, from, these are stop words. Helping words you are using, these are also stop words, right? Is, am, are, was, were, these are also stop words. So in some applications it is required to remove the stop word, in some another application it is not required. So what is the application in which it may be required to remove the stop word? Can anyone tell me? Huh? Name of the topic. Explain that. Topic modeling. Okay. Processing of large corpus of data. So you are also doing the processing in the case of machine translation, but in the case of machine translation it is not required. So in which application it would be applicable? Yeah, a very simple example of this is query search engine. Search engine. In search engine, whatever the query you are giving, is, am, are, stop words would be removed, right? And only through the keywords your query would be processed and relevant documents would be fetched, right? So this is the very simple example of this. Then stemming and lemmatization. This process is also optional and sometimes required, sometimes not required. Similarly, in the case of search engine, you can do the same process just to remove the complexity which is hidden in the text data. So what is stemming and what is lemmatization? So stemming is the process of converting or transforming your textual unit into its root form, right? For suppose that boys is a word which has been appeared. What is the origin of this particular word? That is boy. So boy is the root word, right? So stemming and lemmatization is the process of transforming that thing, the one word, into its root form. But they have their a slight difference between them in stemming and lemmatization. So in stemming, what you will do that you will just remove the suffixes or infixes from them, right? Whatever the suffixes attached in a particular word or infixes attached in a particular word, it only remove that part. But it is not necessary that after removing these part, the word would be in its root form, right? But in the lemmatization process, the word would be in its root form. So this is the difference between stemming and lemmatization. But suppose that went, yes, go, goes, no, no. Yes, went is the if you are converting went to go, that is the lemmatization. But if you are converting goes from goes to go, that can be due to stemming, right? Like coming. So COMING. After processing of the stemming, you will get the word as COM. But after applying the lemmatization process, you will take out the word as COME. So this is the root word, right? Huh? No. At first you will do stemming and then lemmatization, but they have their own algorithm, right? If you are applying the lemmatization algorithm, you will get the root word before applying the stemming process. Now next is text representation. So apart from these text preprocessing, there are various few more stages to which you can opt, like normalization you can do, or any other processes you can follow. So these are some of the example to which you can follow at the time of text preprocessing. Now, numerical values, yeah, you can do. For text, sometimes it is necessary, normalization. Okay, so the next part is text representation. So next phase of text mining process is text representation. So in the text representation, is until whatever text pre-processing part you are following, after that whatever the resultant you will get, that would be in text form, right? Now in terms of applying any machine learning algorithm, you would require the transformation of this textual unit into some matrix form, right? So in terms of converting these things, these textual units into matrix form, you would require some text representation techniques. So one you can follow as the very simple technique to which you can follow to transform the textual unit into matrix form is one hot encoding vector, right? So in which you will generally you will just give the information that whether a particular word in a document is present or not present. If you are writing as one in a matrix, then you are saying that it is present in that particular document, otherwise it would not be present, right? So this is very simple form process or a simple method to represent your textual unit or textual data into matrix form. Another is bag of words, in which you take into account the frequencies of the terms. How many times in a particular document a word has been appeared, right? So that is bag of word, right? How many, what is the occurrences of a particular word is there, right? So that is bag of word method. Another thing you can follow, method you can follow, that is TF-IDF. TF-IDF also you can do, right? So TF-IDF is term frequency and inverse document frequency. The combination of these both will tell you that what is the frequency, how many times it has been occurred, plus what is the significance of a particular word with respect to whole document is there, right? It will give you the information of that. Then another technique to which you can follow, that is word embedding, which generally you will follow in today's time, right? So in the word embedding, whatever the limitations you are facing in the previous method, it will overcome that, right? Like in the bag of word, for suppose that in one sentence one word has been appeared one time, right? And in none of the sentences that word has been appeared in the whole document. So what would happen? That in the column you have written every unique words, and in the row you have written the documents or sentences, every sentence. Now for sentence 1, the cell value for that particular word would be 1, but for any other document it would be 0, right? So what would happen, that the matrix whatever you are forming from them, that would be sparse matrix, which is consisting of very less information, to which you have to process that, right? So to get rid from this, the concept of word embedding has been given, in which you are converting your data into dense vector with high dimensional, right? The dimensionality could be with 512 or more, you can opt. So this is another technique in which word embedding we have various models like word2vec or globe model. They have their own significance, right? Like in the word2vec model, you just finding out the word vector by taking out whatever the preceding words or whatever the forwarded words are there in that particular word. On the basis of that, you are trying to find out the word vectors. But in the case of globe model, it is different from the word2vec in the sense that it start the processing with the occurrences of the word, right? It first make the matrix of occurrences of word, and then on the basis of that it would try to find out the word vector of each and every word, right? So this is word embedding, to which you can follow. Another method, which in the transformer, as you have heard about the transformer in deep learning you are using, in that case you are using the word embeddings, contextual embeddings you can use, right? So contextual embedding is different from the word embedding. Word embedding is the static representation of every word. So for suppose that you have the bank word, for bank word only one static representation would be there, right, in the form of vectors. But in the contextual word embedding, what would be that on the basis of context, in which context that particular word has been appeared, the vector would be formed, right? So that is dynamic representation, right? It doesn't it means that for one particular document, if bank word has been appeared, the word vector form would be different from the another, right? So that is called contextual word embedding we are using, right? Huh. Huh. Yes. Huh. Yes, yes. It follows, and we will discuss this later on, right? We will discuss in more detailed form later on, because this is in our syllabus, right? Word embedding. So these are some methods to which you can follow for representing your text. So another thing, another stage of text mining process is text analysis. So after converting the text data into some matrix form or numerical form, you can then apply the machine learning, right? So now if you want to analyze the data into in terms of finding out some insights or knowledge from them, you can use various methods, right? There are various methods to analyze your data. One of them is text classification. So text classification is a supervised learning approach in which you can you are using your previous historical data, and on the basis of that data you are doing the categorization in defined classes, predefined classes, right? Like if you have the weather forecasting data, sorry, weather forecasting we cannot say, yeah, we can say weather forecasting data. So in that case, if you would like to classify your data into whether tomorrow would be the rainy day or sunny day or any other day, so on the basis of previous data you can classify or you can categorize that data into these labels. So on the basis of these labels, if you are categorizing your data, that is the classification problem. And in this classification problem, you have various methods to which you can opt, like random forest you can opt decision decision tree, you can opt Navier classifier. Various methods has been given, right? So you can use any of them according to your application to just classify your data. Another is clustering. Clustering is unsupervised algorithm in which you have not given previously any label, you have not given the label data, you have data, and on the basis of this data you would like to cluster your data, or you would like to divide your data into various clusters, right? So for that purpose you can use any clustering algorithm, right? So in the case of text, you can apply this thing in various applications, like suppose that if you would like to uh, categorize your data or divide your data into or according to a particular theme, right? So you can identify, you can cluster that particular data according to that, right? According to the theme you can divide that data. Now another is sentiment analysis. It identifies the emotions, tones such as positive, whether it is positive or negative or neutral, right? So it generally uh, uh, process the data. In the case of if you have the reviews data or opinion data or social media data, right? In that case you can apply sentiment analysis. And this is again you can say as the classification problem, right? In which you have given the classes as positive, negative and neutral, and on these three classes you can define your data, you can categorize your data. Next is another technique to which you can follow is named entity recognition. So in named entity recognition is to identify the proper nouns in your data textual units, right? So sometimes it is required that you would like to find out the thematic keywords in your text data. So how you can do that? Thematic keywords can be extracted on the basis of recognizing the named entities. What are the named entities are there, which will tell you that for which particular entity or for which particular purpose this article has given the information, right? So through named entity recognition you can do this. So it is basically the basic technique behind this named entity recognition. You can follow to the technique of pause tagging, right? Because if you will recognizing the part of a speech for a particular word, for all the words which are written in the text, through which you can extract the named entities from them, right? So in machine learning there is a method called hidden Markov model, right? Through which you can calculate you can identify the named entities or pause taggings. Another is you can use topic modeling. You can process your data using topic modeling algorithms. like latent semantic analysis or LDA, through which you can find out the thematic theme of a particular text, right? Whatever the text you have given, and if you would find out that what is the theme which has been hidden in your text data, that can be identified using the algorithm like LDA or topic modeling process. You can do that, right? So these are some of the processes to which you can follow at the time of text analysis. Now, after applying this text analysis process, whatever the results you are getting, on that you can do the evaluation, right? So for evaluation purpose, you have various matrices available to which you can use to evaluate your data, right? Like precision, recall, F measure. So precision, what is precision? Can anyone tell me? True positive divide by total actual positive. Actual in the sense correct, or that is recall. No. True positive divided by true positive plus true negative. ना तुमने नॉमिनेटर में बोला था. So precision is will tell you the proportion of relevant results among whatever the retrieved results are there. For example, suppose that you have made a model for summarization, and now you would like to summarize a text document, right? So you are summarizing the text document which is consisting of 10 sentences in there. Now I am telling you that please identify top few sentences from them to extract that and to generate the summary, right? So whatever the extracted sentences you have given, right, that is we can say as system generated summary, right? Yeah, system generated sentences. So you can compare this system generated sentences with whatever the already available summary is there. With that you can compare, or we can say that gold summary or already summarized form of that particular document. You are doing the comparison from them, right? So if suppose that two sentences has been overlapped in between these two, so the total overlapping sentences divided by total retrieved sentences. So for suppose that you have retrieved 4 sentences, so total overlapping sentences, that is 2 divided by total retrieved sentences, that is the precision, because it will tell you the proportion of corrected result over the whatever the retrieved result is there. On the other hand, if we talk about the recall, it will tell you the proportion of corrected results over whatever the corrected form of summary is there, right? Or we can say from all the data. Or suppose that in your corrected summary there are 5 sentences, right? So total overlapped sentences divided by whatever the in reference summary you have given the sentences. That is recall. Got it? Now F1 is score. What is F1 score? Harmonic mean of precision and recall, right? So that is 2 into precision into recall divided by precision plus recall. that is F1. But what is the actual formula of F score? This is F1 score. If I am telling you F score, what is the actual formula of that? What do you mean by 1 in this F1 score? So the actual formula of this is, मैं ऐसे ही बता दे रही हूँ, उतना दूर कौन जाए. So the actual formula of F score is 1 plus beta square or alpha square, any variable you can take. 1 plus beta square times precision into recall divided by beta square times precision plus recall. You can note down that 1 plus beta square times precision into recall divided by beta square times precision plus recall. So when you will apply the value of beta here as 1, the value of beta is equal to 1, then you will get the F1 score formula. Right? Then you will get the F1 score formula. But what it exactly means? It means that you are giving the weightage to precision and recall both matrices equally. You can analyze this. If you are giving 1, in that you are giving the precision score and recall score both equally weightage. Right? Now you can do another thing, that if you want to give the more weightage to precision matrix or more weights to recall matrix or recall score, you can change the value of beta according to that. Right? So on the basis of this, you are doing that. So now one question remains here, why we are using here harmonic mean at the time of finding out the F1 score. Why we are using harmonic mean? Why we are not using simple arithmetic mean? Somehow she is correct. So what happens, that suppose that by an example I will tell you, that for suppose that you have the precision value as 0. How? For suppose that you have extracted such kind of sentences in which for suppose that only one sentence has been overlapped, right? So what would be the precision value for that? In out of 10, what would be the precision value? That is 1 by 10. Now if we are retrieving all the sentences, I'm not giving you the length of the summary, right? I am giving you that extract the sentences, right? So in the extraction of the sentences, if you are extracting all the sentences, right? So there would be very high chance to overlap the corrected sentences with the reference summary, right? So all the sentences in the reference summary would be overlapped, divided by whatever the retrieved sentences are there. So in that case, what would happen, that you are giving the precision value, precision score as very high, and recall value would be very low in that case, right? For suppose that in the reference summary, you have 4 sentences, right? 4 sentences you have. So in the system summary you have 4 sentences, then you will get the what is the recall value of that. The recall value of that would be number of overlapped sentences divided by whatever the sentences is there in system generated summary. So in that case what would happen that sometimes you may experience that the precision value is very low and recall value is very high. So what would be if precision value is very low and recall value is very high? In that case, if you are going through with the arithmetic mean, right, simple mean you are trying to find out, in both cases what would happen, whether the recall value is very high or precision value is very high, in both cases you will get the at least 50% correct result. At least 50% correct result you will get. But is it would it be actually 50%? No, it would not be actually 50%. It is just because you have extracted all the sentences, right, which is not correct. So you would like to give the balance between precision score and recall score. So in that case you are using harmonic mean. In the case of arithmetic mean, you will get more results or more biased results you can get. But if you want to find out the actual results, in that case you should opt harmonic mean. So that's why F1 score is meant is calculated using harmonic mean of precision and recall, right? So this is about the F1 score. Now after calculating if after doing the evaluation of your results, you can also interpret, you do the interpretation or do the visualization, because by seeing the numbers you cannot easily interpret the results, right? So it needs the visualization step in that. So for that, for visualization of your results, you have graphs, you have heat maps, you have word clouds through which you can do the same, right? You can visualize your results more easily. For example, you have performed the clustering of words in your text, right? Now if you are visualizing these clusters of words using word cloud, it would be more easy for you that what are the different words are there and what is this distance between these words are there, right? So through word cloud you can do. Now the last step which you can follow, that is iteration and refinement. So if you are using bag of words model or some basic approaches to transform your textual unit into matrix form, uh, you can opt some advanced techniques instead of that in the refinement, right? Once you have done and you have faced that your results are not accurate, so in that case what you can do, you can refine your strategies, whatever in every stage you have followed, right? So like at the time of transformation of textual unit, whatever the approach you have followed, you can use some another techniques which can give the best better results, right? Or you can fine tune your hyperparameters like learning rates, you can uh, fine tune, or number of epochs, or any other things you can, which comes into the category of hyperparameter, that can be fine tuned. Or you can use more domain specific knowledge to tailor analysis to industry needs, right? So like if you are doing the processing in the case in the domain of medical, right? So more medical terminologies you can define in terms of finding out the domain knowledge, right? So these are some of the techniques to which you can follow at the time of iteration and refinement. So this is the whole process of text mining, and the key techniques to which you can follow in text mining is text information retrieval, natural language processing, information extraction, text classification, clustering, topic modeling, text summarization. These are some key techniques to which you can follow. So this is about the text mining introduction. Now from the next time we will discuss about the text collection, data collection process, and then after that we will come to the another processing techniques one by one. Now if you have any query, you may ask. Huh? चैट जीपीटी क्या कर रहा है? चैट जीपीटी पोजिशनल एनकोडिंग यूज कर रहा है. नहीं पता ना? पोजिशनल एनकोडिंग यूज करता है. मतलब हर वर्ड के लिए एक पोजीशन डिसाइड है. जैसे वर्ड एम्बेडिंग के लिए एक वेक्टर है, ठीक है, हर एक वर्ड के लिए वेक्टर फॉर्म होता है, वैसे वर्ड की पोजीशन के लिए भी एक वेक्टर फॉर्म होता है. हम्म. On the basis of similarity of data. How much a particular data is or text is similar to another one. Generally cosine similarity. क्या चीज? हाँ. मेरे कान में प्रॉब्लम है, मुझे थोड़ा सा कम सुनाई देता है, मैं पहले ही बता दे रही हूँ. Any other query? No, 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 no. RNN part we are not. Yes, yes. Maybe we can cover, but after covering all this thing, if we get time, sometime we can cover RNN. Huh? Sequential model. RNN, LSTM, GRU, we can. But let's see if we get time. अटेंडेंस हो गई आप लोगों की? आज इतने कम बच्चे क्यों आए? आज तो धूप निकली थी. हाँ? बाहर से बुला देना उनको, बाहर से बुला देना. ये आज की है? कितने बच्चे हैं इसमें? 94 है क्या? 94 है क्या? इसको वो कर दो, सेव करना है ना। PhD स्टूडेंट्स कितने हैं यहाँ पे?